Hello again, this is Dr. Joe Snyder, and this particular video is going over hypothesis testing. So this is a z-test for the mean, meaning that you're getting a z-test statistic based on one sample. And the way that this spreadsheet works is that your hypothesis test, the null, is in B4, the value for it. So that might be that your H0 is the population mean is 368 in this case. Now your H0 and H1 are opposite of each other, so that would mean that the population mean is not equal to 368 as your H1 or your alternate hypothesis. Excuse me. The light blue area is data entry values that you put in. Things like sample size, sample mean usually are calculated values and then entered based upon your raw data. All the rest in yellow are calculated for you. Even the interpretation as to what judgment call to make is sitting here in the cells at the bottom of the yellow sections. There are three sections: a two-tail test, meaning that you have two rejection regions, one on the left, one on the right. A lower tail test. This is for if you have an H1 that has a less than sign in it. And the upper tail test, if you have an H1 with a greater than sign in it, that's the area you would use. So you don't use all three areas, you use the one that's appropriate for the H1 and H0 that you have. The two-tail test, I forgot to tell you, it was H1 being not equal to a number. So two-tail is not equal to a number for H1, lower tail test being less than in H1, and upper tail you have a greater than sign in H1 for your value, for your alternate hypothesis. So this is pretty simple. You just enter your numbers, you get the values back, and then you make your interpretation. There are two different kinds of methods to do hypothesis testing. One's called a critical value method. So you're seeing two critical value in the two-tail test. You're only seeing one in the lower and upper areas because there's only one tail. The p-value, there's a consistent way to know whether to reject the null hypothesis with the p-value test, and that's if the p-value is, or the level of significance, then you reject. In the critical value testing, you take a look at the rejection zones and see if your z-test statistic is outside the bounds. In this particular reason, 1.5, that value, is not outside the bounds of minus 1.96 to positive 1.96. So same thing with the p-value. 0.1336 is way above 0.05, and therefore we say do not reject the null hypothesis. Remember, you only make statements about the H0. You reject or do not reject. Sometimes that can be worded differently. The H1 is always what you're trying to prove. H0, the reason why they call it a null hypothesis is that nothing's going on. The value is equal to something, or a difference is zero. Basically null is happening. That's why I call it the null hypothesis. The H1 is always the area that you're trying to prove. So something is happening. So there is a difference. There is a change. So at this point, that's one hypothesis test. Now I'm going to go over another one here called the t-mean test. And the key difference here is that you now have sample standard deviation in row 8, where we did have population standard deviation before. In this case, we just don't know that value for the population standard deviation. So we have to use the sample standard deviation, which is less accurate. It's just one sample worth of data. You don't have the whole population worth of data. But the operation of this spreadsheet is exactly the same. It's just now that we are dealing with sample data, we have a T statistic, which is more of a gross kind of a comparison against Z, usually larger values than Z, which creates larger confidence intervals, larger or smaller areas where you're going to reject. So what you're wanting to do is the same thing. You look at the t-test statistic instead of Z. It's calculated a little differently, and then you do either the critical value test or you do the p-value test. Remember, if you have the critical values and you go outside of those boundaries, then you reject. If the p-value is lower than alpha, which in this case is 0.05, you reject. So none of these reasons here are showing up, so you say do not reject. Also, this is the same way. You have a two-tail test, lower tail test, upper tail test. Okay, so we've gone over two tests that are around means, and then this last test I want to show you is about proportion data or ratio data or failure success rate type data. So you have the similar operation. The light blue areas are your data entry. All the yellows are calculated for you. So operates exactly the same way, just different kind of data coming in, where you have the number of items of interest, which are how many items within the sample size had a certain characteristic. For instance, if I had a store and I had 1,000 people come in during the day and 500 actually bought something, that would be the number of items of interest, how many people bought something. Okay? Otherwise, this operates exactly the same way, and you have the two-tail test, the lower tail test, and the upper tail test. Thank you very much for listening to this video, and these files can be available on request.